Good morning. Very happy New Year to everyone. Thank you so much for joining this webinar. Uh, I hope your New Year celebration was great and you have made your New Year resolutions for 2020. So, yeah, I also have made a lot of resolutions, as well as Indian Blockchain Institute also has made resolutions for 2020 to make, to offer you with more quality content, hot topics, which we'll be doing in our webinars, getting more products regarding the training that we are doing. Okay. So today's session is part two of the series of blockchain in Industry 4.0. So I'll start off with first just revisiting to what we had done in part one, just a small revision, and then we'll go ahead. So, if you remember, I had defined that Industry 4.0 is the information intensive transformation of manufacturing in a connected environment of data, people, processes, services, systems, and IoT enabled industrial assets with the generation, leverage, and utilization of actionable information as a way and means to realize smart industry and ecosystems of industrial innovation and collaboration. Basically, if you remember how industrial revolution came into existence is when there was a disruptive technology which was invented. A revolution happened in the manufacturing space, which motivated the growth of industry all across the globe. First, it was steam engines, then electricity, then the internet and computers, and now a very, very connected environment and an ecosystem for an industry to function along. Okay. So basically, if you remember, I told you that all the technology which is there in Industry 4.0, we had seen some of the technologies in Industry 4.0. We'll be seeing that later as well. So you so you saw how information intensive it was. It was based on all about data, and data. Analyze data, predict what would happen so that you can take the right step at the right time to get the maximum output, right? Or data getting transferred between devices, IoT. All these things comprise of basically this is what optimizes production and boosts growth in the industry. So that was all about Industry 4.0. Now, just a quick revision on what is blockchain, because the intent for today is how blockchain is a part of every technology which is there in Industry 4.0, how it is integrated to it, and how it benefits the industries. We'll see that today. Okay, so the definition of blockchain as it goes is blockchain is a distributed ledger shared across a peer-to-peer computing network. Each computer node in the network holds a copy of the ledger, so there is no single point of failure. Every piece of information is mathematically encrypted and added as a new block to the chain of historical records. Various consensus mechanisms are used to validate a new block with other participants before it can be added to the chain. This prevents malicious actions without requiring a central authority. Now, what I will look, the thing here is why I'm defining blockchain is you need to know at least what is blockchain before we proceed ahead. You need not know the exact working, how it works and everything, but just a very high level overview about how the technology works. Okay, so in blockchain, as I mentioned in part one, that any data transfer that takes place is called a transaction. So if a transaction is requested, what happens in that is, first of all, blockchain is a decentralized network, meaning it doesn't have a central entity or a centralized architecture wherein the central party is supposed to take care of the transaction handling, exchange, execution, storage, integrity, security, and everything. So, whenever there is a transaction in the blockchain network, it is first of all broadcasted to the peers in the network. As I told you, there is no central entity in the network to take care of the transaction execution and all the processes related to the transaction. The entire network is decentralized. It consists of peers in the network rather than having a client server architecture. Okay. So then what happens is every peer in the network validates the transaction independently without the influence of each other. So there is no influence as per, uh, it is like a fresh set of eyes for every transaction which is there. And after that, a certain number of nodes are responsible for putting these transactions into a data structure called block. Now, once they have put the transaction into a data structure called block, they have to work on the block. Basically, you might have heard about mining. We are not going to go into the details of that. So there is some process through which there is a validity parameter. Basically, a validity stamp has to be there on that particular block. That is the data structure. After that block has been formed by the because of that process, through that process, the block is broadcasted again to all the peers in the network. As the transactions were independently validated, same here the block is also independently validated by all the peers in the network, and then they add it to their ledger, and thus your transaction is complete. And this is how a transaction executes in a blockchain network, which is a decentralized network. This is the core feature of blockchain. Now, what blockchain has to offer you is, I told you that it offers you decentralization. As you saw, there was no centralized entity to carry out the process. Everything was decentralized. The immutability factor, which is an inherent feature of the blockchain. The immutability meaning the data structure is in such a way that once the block has been chained to the previous blocks, what happens here is you cannot go and change any data. It is there forever. So you cannot do any CURD operations on the ledger. That is create, update, read, delete. You can only append and read. So that provides you with something that is tamper proof. Basically, it is immutable. Disintermediation. I told you in the last part that there is something called as a smart contract component of the blockchain, which is if the transactions can be immutable, meaning the code can also be immutable. Basically, you can write the code and even the author cannot tamper with the code. Such a beautiful thing. And smart contracts executes on their own when certain conditions are met. So automation is there. So you don't have to rely on third parties to provide you with the trust for the code base or the contract, as well as the execution of the contract. It can take care of itself. And by the intent for this session was to show you how blockchain is a catalyst for trust building, so that technologies which are there, which are cutting edge technologies, amazing technologies which can help industries transform. The only barrier is the trust factor. Either you have to trust the third party, or a lot of other legal bodies have to come in if you have to do business using these technology. So blockchain comes into picture when there has to be trust building. So it's a technology of trust. So last time we had seen that industry 4.0, it's all about smart factory, basically automation, integrated processes, and making the max out of the data that is generated. So in that, we saw certain technologies I had spoken about in the last session. That's cloud and edge computing, integration systems, simulation software, additive manufacturing, big data, augmented and virtual reality, robots and AGVs, cybersecurity, cyber physical space systems, IIoT, that is Industrial Internet of Things. And the various applications which are there, which is associated to those technologies, as we saw: smart logistics, smart utilities, mobility, smart agriculture, and smart appliances which are there. Now, I told you these technologies are not isolated from each other. Rather, they complement each other. They work with each other. There is a lot of interaction between these technologies. Basically, the applications of these technology interact a lot of with each other in the same industry itself, for any in the same process, also in the same ecosystem. So there has to be a seamless communication. There has to be a seamless way of which these applications can communicate with each other, devices can communicate with each other without having to consider about what is the security aspects, without having to rely on third party for the security, basically for the trust. Rather than that, a technology in itself that complements all these technology for its security aspect, that's blockchain, can help. We're going to see certain technologies among them. We'll take up cybersecurity and CPS in another webinar due to it's a little bit of a vast topic. So moving ahead, we're going to see certain technologies in 4.0 as per what are and we're going to categorize as per like what are the current challenges each technology has, how blockchain integration takes place into that technology, into what aspects and what are the benefits out of that, what are the adoption challenges which are there when it comes to blockchain being adopted in industry 4.0. There are certain challenges because blockchain is an evolving technology. It's still growing from its birth from Bitcoin, that is way in 2009 to now. It's evolving as per to meet up with the industry standards. Okay, Parag has a doubt like what is the meaning of 4.0? Uh, I would suggest at the moment, like you can go after the session is done, you can go to part one, view a video, and you will better understand what Industry 4.0 is all about. Is it okay? Great. Okay, so let's go ahead. So the technologies that we're going to see today is augmented and virtual reality in Industry 4.0, additive manufacturing. As you know, the name is 3D manufacturing, 3D printing, cloud and edge computing, horizontal and vertical integrations, big data analytics, industrial internet of things. You all know about IoT. Double IoT is just industrial internet of things. The simulation softwares, robotics, all these are the technologies of industry 4.0, which core intention is to optimize the efforts and get maximum productivity. And we are going to see how blockchain plays a role in each of these technology to boost it, to further take it ahead, as well as I told you, to act as a catalyst for trust building so that you don't have to rely on third parties or intermediaries for the trust factor. You can rely on the technology itself. So, augmented and virtual reality. Now, it sounds like something out of a sci-fi movie, but it is not. It is something that's happening right now. It's like it has come to terms that it is becoming real. It's not just a concept anymore, and it is being optimally used, and it's helping industry a lot. So, what is first of all? I'll just start off with a brief this thing like what is augmented and virtual reality. I know many of you know what it is, but still, just a brief introduction to that. Now, augmented devices, that is basically augmented reality devices, display virtual elements on top of the real world physical environment. As you can see, a guy is working on an engine that is actually a BMW engine, a four-cylinder. I guess it's a W V8. Okay, I guess I'm not sure. Whatever. Okay, fine. So that person is working on a real object, that's the machine, but because of the device that person is wearing, is able to see certain fields in his certain aspects in his field of vision, which is showing certain features or details about the machine that he's working on the engine that he's working on. So that is basically augmented reality, that there is data being portrayed on a real world physical environment. Okay. So that can be used to a vast extent when it comes to maintenance, when it's very difficult to diagnose and understand where the problem lies or to how you're supposed to repair a machine or take care of the maintenance. But if you have devices, which is there right now, such devices help engineers to see like what are the details, what are the attributes of the different components in that particular machine, and diagnose it with the device that you're wearing in real life and in real time. Okay. So basically, the offloading techniques, basically what happens is like you have either fogs or edge computing the devices, which takes care of the process, and then they update the cloud rather than putting the entire load on the cloud. So you see that it is trying to improvise itself as a peer-to-peer technology, but from scratch it is not. Blockchain from scratch itself is a peer-to-peer technology, and yes, it can support vertical integration because of that. Now let's come to big data analytics. Now, Industry 4.0, as I told you in the starting itself, it is information intensive. So, lot of information is being generated by every point of contact in the entire supply chain or the entire business process, and every entity taking part in the process is generating a lot of data. Now, their data first, it used to be a correction mechanism. You analyze the historical records, and then you had to take a decision. Okay, this had happened like this. Okay, then there is analysis done. Rather than that, take the pattern of what's happening right now and predict what will happen later on. And that's what big data is all about, right? So here there is a problem is now we are talking about data, right? So there are three major issues that big data and data analytics face. That is the data collection, data trustworthiness, automated reliable data circulation. Now, when it comes to data collection, if you see, I told you, like in Industry 4.0, there are multiple, the entities which are there in a business, which they are connected in a business, are generating a lot of data, right? Unstructured data, structured data, different sources of data, okay? And they're going, so basically, so much of data is generated from so many entities in different forms and through different mediums, and then you channelize that and then you put it into a particular centralized storage, and then you do analytics on that. So basically, to gather the data itself is a big task. You have to have data warehouses, then you do your data mining, a lot of process which is involved, data cleaning is involved. What if you could give a very seamlessly integrated network through which this data can be interchanged between each other, or through which that becomes a medium to collect data? Basically, you connect all these entities because they are, as you see, it reflects decentralization. There are so many entities, and you cannot make one entity as a centralized entity. But for the process to take place, for the business to run, you have to rely on a third party for making everyone coming to the same page. Rather than that, have a platform. Rather than that, have a technology which connects them in a seamless manner and integrated manner for data collection, right? And then the data which is being collected, that has to be of trust. It has to be trustworthy. If you remember a little bit some while back where I was talking about horizontal integration, whatever happens in a network is reflected to everyone in the network, right? So there has been authenticity of that particular data, and then it is stored into the ledger. So when it comes to blockchain, first of all, the data generated the data generated has to be validated by everyone in the network. Second, once the data goes into the records, it cannot be tampered with. So yes, it provides you with security to the data. And then the third aspect, that's the smart contract part. I've been the smart contract part that I was talking about. Okay, just a minute. Shrishti raised, you have a doubt. You can put it in the chat. If anyone has a doubt, please keep putting it up in the chat. And yeah, and I will take it up at the end of the session. Is it fine with everyone? Guys, please respond to this. If you guys have doubts, please start putting up in the chat. At the end of the webinar, we'll take those doubts up. Is it fine? Yeah, it's okay. Okay, great. Okay. Okay, where were we about big data? Yeah. We were on the third aspect. That's the automation part. If you remember, I told you that blockchain helps you with what do you call is smart contract. One of the elements of blockchain is the smart contract part. So
ठीक आहे, तुला ती लिंक पाठवतो, त्यावर रजिस्ट्रेशन करतो. ठीक आहे.
हा ठीक आहे, पाठवून दे. ठीक आहे.
हा.
ओके.
Okay. Sorry for the disturbance. Okay, fine. So yeah, the automation part that I was talking about. So the smart contracts are self-executing contracts, right? So what happens here is, I do self-executing contracts basically whenever when a certain set of conditions meet, then the contract has to execute on its own as per the conditions defined in the contract, and those conditions are immutable and no one can tamper with it. Okay, so big data analytics is all about predicting what's going to happen and what steps should be taken. And then the management, and then there is a decision-making process after the analysis has been done, and it has to be implemented. Rather than that, if this prediction can be converted into implementation through such a contract, how beautiful it is. And that's how blockchain helps big data. Okay. Coming to IIoT, Industrial Internet of Things. Okay. Basically, everything is about IoT. It's all about sensors collecting data, then the processes happening and everything, cyber physical spaces. Everything is all about sensors itself, right? Now, let me come to this point. How blockchain is going to help? There are various things which blockchain can do to help the way IIoT works. But there's one core thing that is of interest to me, basically, is because if you see blockchain, it has already proven its use case, the digital currency use case, that's with Bitcoin, that you're able to transact a particular digital currency without having to rely on any centralized entity like a bank, government, or anyone. And it is of value. It's of value because of the technology. That's the blockchain technology. Bitcoin was born because of blockchain technology, or it's like the other way around as well. Okay, so if that can happen, basically monetary transactions can take place without a centralized entity coming into picture because of blockchain network, right? What if the same principle can be applied in IIoT? In the sense, here, in the case of Bitcoin, humans are doing transactions with the help of wallets. What if, instead of humans, machines are doing transactions within themselves using some sort of currency that they have agreed upon in that particular network in which they are connected? And all the transactions are recorded in an immutable way, and it is known to everyone, as well as smart contracts can get executed on basis of those records. How beautiful it can be, right? So yes, through this, you're optimizing IIoT and you're implementing another economical layer over the technical, wherein the devices and the machines which have these sensors are able to do transactions with each other. Machine to machine payment can happen with the help of IIoT. Now, one such example of IIoT, if I have to see, is like IIoT is all about automation, right? So for example, if you have autonomous, no, that's the, let's come to machines. Okay, the part of this will be covered in robotics, like what I'm talking about, this commercial part. Okay, but as you can get this, right, like machines paying for themselves and interacting with other machines, that can be done through blockchain network. Now let's come to the simulation aspect. Now, industrial simulation, what is it all about? The simulation aspect is that if you have to define a particular structure, manufacture a particular machine, an engine, or anything, you actually do it virtually before rather than doing it the physical way, right? Because physical is expensive. and corrections will cost a lot, right? So what you do is like you create a virtual simulation of that particular physical object or a product that has to be manufactured or made or constructed in a particular software, and then you test it with real life situations and you see how it performs, and then you can make the corrections virtually. And then once you are satisfied with how it has been and it is working as per all the conditions, then you proceed ahead into the real manufacturing of the real product or the basically the real life object. Now when you're doing this, first of all, there's some design aspects which come into picture, as I told you before. So obviously, again, there is IP involved, because design as per the machine design, it can be an engine design or whatnot. Okay. The second aspect here is it's trying to take in real life data. Like, first of all, it has to take what happens in the real world, put it into this simulation, and then see what you have designed really works, considering the situation, real life situations, right? So this real life situations data has to be very accurate, right? It cannot be tampered with. It has to be uh, it has to maintain its integrity, because just imagine the data that you're putting the data that you are putting it the data that you have has some flaw in it. Okay, and that flaw, you're trying to test it with the simulation aspect and it works out in the simulation, but there was some tampering done, and then when you start off with the real production, the flow carries on, and yes, then there is a correction that has to be done. So again, an optimal way of again, just to enhance the way simulation works, just to provide it with the security aspect, blockchain technology can be used. So when it comes to robotics, okay, so we have covered a lot of technologies. I know it's being long, it's going a little bit lengthy as I thought. I didn't expect it to go for so long. Anyways, just a minute. Okay, so we are talking about robotics here, right? So robotics, I told you, is it's about that IIoT thing. So there are cobots and robots. Cobots are some that work with the help of human interactions. Basically, both the human as well as the robots work together. And there are robots, and there are AGVs, that is autonomous ground vehicles, which you can see in the images, which they follow a path or an or an infrared. Basically, it can be a laser, this thing, or a physical path which they follow for doing certain stuff, like taking goods from one place to the other in a warehouse. So that all can be done with the help of robots, right? Now, how blockchain can take care of this? First of all, the interaction between these robots is happening in a decentralized way. So obviously, you need a technology which is from scratch, a peer-to-peer technology, which can take care of such an interaction in a very seamless way and provide security as well. And yes, for the interaction part. Second, when I spoke about that, the monetary part as well. Now, suppose it's all about robotics, right? Automation. Now, robots provide automation, which so if you think of autonomous cars which are there, okay, so autonomous driving cars or cabs which are going to come in, which are actually there right now and going to come into mainstream in the near future. Okay, so what happens here is you, with the help of blockchain technology, you can have a commercial layer over it, wherein if an autonomous, you can pay, the car can pay for its recharge. Basically, electric vehicles is the future, right? So if there is a network wherein there is a particular currency which is traded among by the energy partners as well as the as well as the car, autonomous driving car, and when the car is about to get charged in some charging station, it can pay through the help of that particular currency. It can accept that payment of that particular currency, the digital currency in that ecosystem, and the security to that particular digital currency can be provided with the help of blockchain, thus providing machine economics. So, so we are almost done with all the technologies which were there. Just to run through, we saw how blockchain is used in AR and VR. We saw how it has been used in 3D, that is additive manufacturing, 3D printing. We saw how cloud and edge computing basically is moving towards blockchain only, because edge computing is something that cloud is an architectural implementation into the cloud computing, current cloud computing architecture itself, just to balance the load which comes to the cloud. Then we saw how horizontal and vertical integration, which is supposed to enhance how businesses interact with each other to create or to optimize the productivity. Then big data analytics, we saw that the source of the data has to come from basically the data collection has to happen in a very uniform manner through one single platform or a network such as blockchain. And then the source of the data has to be trusted. That is, once the data has been into the blockchain, cannot be tampered with. And the author of the data also has to, basically, there is a signature which is associated to every data that goes in the blockchain. Okay, which shows the who is responsible. There is an auditability factor as well. Who had given what? Then the third aspect is of automation with the help of smart contracts. Automation is supported when it comes to analytics. Basically, if there is a prediction that has been done, so you can use that predictive analysis and convert it into an implementation. Then, as we saw, IIoT, the sensors which are there all which is a crucial part of the industry right now. So a lot of data has been generated, and I told you, right, all the technologies which you see here is not working in isolation, but with each other, and these interactions are happening. And to provide security to those interaction and a seamless integration, blockchain can be used. We saw with simulation as well, where we saw that before a product or basically a structure is made in real life, it has to be virtually created first, put under test using real life scenarios, and then you can take a decision or you can make the necessary changes into the design. Now, whatever situations you consider, that's nothing but data. So you have to have tamper-proof data, immutable data. You have to have good data that you can trust. Then the robotics part, where I told you that machine economics can come into picture because it has already showed, it has proven the use case that it can support a decentralized monetary system such as cryptocurrency like Bitcoin. That same thing can be applied to robotics as well. So just a minute. Oh, sorry. Okay. 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 So there are adoption challenges. It's not that easy. I told you that a lot of work is being done in the blockchain space. A lot of evolution, like the blockchain technology is evolving day by day as we speak. So there are a lot of scalability issue which is there as per the number of transactions that can be performed. So for which, like it depends upon what sort of platforms you use. So there are certain public platforms, there are certain private platforms. Ethereum is a public platform. It's public network. So when it comes to public network, there's a lot of mining involved for transaction validation and all. So basically for that, they are switching towards proof of stake. There is sharding getting implemented into Ethereum network. So yes, if there is an issue, these are the challenges which are there, but there is work being done into those as well. Okay. So this, like I told you, there has to be an agreement. Now, those agreement is basically an algorithm which is written. So there are various types of agreement mechanisms, basically consensus mechanism like proof of work, proof of stake, PA, then something called as a Byzantine fault tolerant, PBFT, practical Byzantine fault tolerant, Raft. So depending on the platform, depending on the different kinds of use cases, depending on the type of business, these consensus algorithms are decided. The privacy and security aspect is if it supports and look, first of all, it provides security with the help of some cryptographic keys. That's a private public key infrastructure, because for any transaction you need to conduct, it has to be signed using a private key, and it will be addressed that the source will be addressed using the public key. So if that's the point, then if sensors have to be connected, the sensors has space constraint. Now if they have space constraint, so it is a little difficult for them to adopt such a crypto system. So still, there will be enhancement. And look, if it comes to a public blockchain, if there is mining involved, yes, there's a lot of energy which has been put into it. And since it is happening in a decentralized way, since it provides you with security, there is certain latency, and you cannot expect a throughput if you're adopting a public blockchain. But when it comes to a private blockchain like Hyperledger, Fabric, and all these things are taken care of. The required infrastructure can vary depending upon the type of blockchain you take up. And then comes the part where regulatory and legal aspects. Since it's a very new technology which is evolving and it's coming into mainstream right now after a decade. So what happens is there is a lot of standardizations that people are still working on, like IEEE or ISI or ISO are working on standards, how these technologies are supposed to be implemented. What are the frameworks? If it comes to currency, then there has to be a lot of regulations. Basically, if you're having a digital currency, as you saw, a lot of things happening in India, that the government is against cryptocurrency because it's not regulated. It doesn't have any frameworks which it follows, right? But if such a thing can really help industry to grow, which I was talking about, the monetary layer that can build over the IIoT, over all these technologies which are the machines which can communicate with each other. So there is currency involved, right? So if there is a currency involved, there has to be regulations as well, and all the legal aspects of how it has to be, how a solution has to be designed and implemented. Work is being done in all these things, but these are the adoption challenges which are there because these are not predefined. It's in the it's still not matured enough, is what I would say. But as the technology is evolving, it will soon. So, conclusion to this series is that Industry 4.0 is a paradigm and is changing the way how factories used to operate and now how factories will operate because of the latest technologies, which I spoke about. So, and one of the technologies, now the intent for this session is to show you where blockchain technology actually fits in. And you saw that maximum of the technologies which are there in 4.0, blockchain could complement it to optimize it, to provide the security aspect, to provide the trust factor. Okay. So, since it was like the cryptocurrency was just an application, the first use case of blockchain technology, and it was successful. So, it has proven that it can work. So it adds, as well as the last part was the automation part as well. It's not just the security and trust factor, but the automation also supported through smart contracts, which are immutable and self-executing contracts. I hope this session was informative to everyone. There are okay. So I'll take up the doubts. Just a brief introduction about. Just want to talk about the company, Snapper Future Tech. So, Snapper Future Tech is a blockchain development company, and we have been into a blockchain space since last 3 years. So, you can visit www.snapper.tech to explore more about the offerings of our company and stay updated about the latest news in the blockchain space with the help of snapperbus.com, which is a part of Snapper Future Tech itself. And Indian Blockchain Institute, which is the training brand of Snapper Future Tech. So go onto our website and you can see the different certification programs that we are offering with related to different platforms like Ethereum and Hyperledger, as well as there are 9 certification programs that we offer and 12 different modules. Like if you're a guy who is already into the blockchain space and just want to upgrade your skill, you can enroll for one of the modules that you feel like, or you are a person new into blockchain, any kind of person, like it can be a business person, a person from the development background, a person from the analysis background, a person from administrative network setup background. For every aspiration, we have different courses. You can check it on our website, www.blockchaininstitute.com. And you can connect with me on info@indianblockchaininstitute.com. Follow us on Instagram for all the updates regarding our upcoming webinars on the courses. And I'm declaring today that if you see the website today, it's going to be our old website because on 6th of January, we are going to deploy our revamped web portal for Indian Blockchain Institute to provide you with a seamless experience of going through our courses, seeing whatever we have to offer, and enrolling from there itself. Okay, thank you so much. Now, I would take up the doubts. Okay, so Srishti has, doesn't the large amount of data clutter the network, the blockchain network? That's all right. Oh, okay. Srishti, first of all, data cluttering happens when a lot of data is pushed towards a centralized storage, right? Which is responsible for storing and execution of it. And I told you that uh, in the cloud architecture itself, there is an implementation which is made because of so many different sources of data. That is the edge computing, or you call fog or edge computing. That's having the processor there itself. Now, blockchain is a decentralized this thing. So there are multiple nodes, multiple peers in the network. So you are not pushing the data towards one peer itself. There can be a peer and sensors associated to that particular peer, and all those peers can be connected with each other, which I think can solve the problem of data cluttering. So thank you everyone once again for joining the session. Uh, the upcoming webinar, I'll be updating you guys about the upcoming webinar, the topic and everything. And since we were not able to cover cybersecurity and cyber physical spaces in this session, we'll be taking up in some other session. Okay. Thank you for joining. Once again, a happy new year. Take care.